Good morning, all of you. Today we have two points to be discussed. One is, in continuation of our discussion on establishing the product function, we are going to learn another new technique called FAST. F-A-S-T. We are learning, as I told you in the introductory class itself, the whole subject is learning certain tools of how to systematically do product design. So these various tools will be useful in systematically designing product design. We have learned many tools already. Have you learned any? We have learned what is called subtract and operate. This is a tool which is very, very useful. As you will be seeing it, we will be again recalling the subtract and operate. Reverse engineering is another tool. Voice of the customer is another tool which can be effectively used. So, today we will be learning another technique called FAST. So that is the first point that we will discuss. And the second point is the term assignment 2 and certain other related issues. Okay, I want to give a brief input for the second assignment. That will also be discussed today. Now it will be discussed in greater detail later. I want to have this introduction today. So these are the two things that I will have. So roughly I will take another 45 minutes discussing about FAST and another 40 minutes discussing and providing certain inputs for your second assignment. Is that fine? Okay. Now I told you establishing the product functionality is a very important step in the design phase. So you should be able to clearly establish what the various product functions are. So what we are going to learn today is a tool for achieving this, is a technique for achieving this. Next slide please. Now basically how the whole thing, how this fits into the whole scheme of things. Now you have the customer's requirement coming in. You have the customer's requirement which is coming inside. So based on the customer requirement, we are identifying some broad process. Then we have to identify constraints. In the last discussion we saw the difference between a function and a constraint. Do you recall? Okay, there are certain functions to be performed by a product and there are certain constraints under which the design is to be carried out. So there are functions and there are constraints. So we have to distinguish the constraints. And here the technique branches into two. One is generating a function tree, creating the task list. So these are the two. There are associated techniques correspond to these two. What is the first thing? Generate the function tree. So you have a product, it has a primary function, it has many secondary functions to be performed. Now how these functions are performed, if you go from the function point of view, then this is one different approach. The other approach is, what are the various tasks performed by the product? Probably the distinction you will appreciate better after seeing the two techniques. Then if you are selecting a function tree, after arriving at a function tree, you will check whether the customer requirements are satisfied. You will check back with the voice of the customer. Then you will see whether there is any alternative functional structures. Finally, you will identify the product architecture, you will identify the sub-assemblies, assemblies, and how the whole product is constructed. The whole product can be viewed as putting together of various sub-assemblies. Sub-assemblies can be made of parts and sub-assemblies. So that is the product architecture. We have seen that already. So this is one way, or you can create a task list, the various jobs, the various tasks that the product will perform. Then you will go aggregates, sub-functions. Okay. Then you will check whether the whole thing works. Then again it will be compared and the flow takes place. About this branch, we will come to it later. We will talk about this branch today. Now what I have to do is, given a product, I have to identify what are the various functions that the product is supposed to perform. Given a particular product, I have to identify the various functions that the product is supposed to perform. Next slide please. Now the tool, the technique that we are going to study today is function analysis system technique. See, why we rely on these tools? The objective, the reason why we resort to such tools and techniques is, it is a systematic method, so the chances of missing some essential aspect is not there. Okay. Given a product, I can always identify what all the thing it does and how it is done, how it is to be done. If you are designing afresh, you can say how it is to be done. I can always do that. But in the process, I might miss some essential aspects. So when you have a structured approach to the whole problem, you are sure that you don't miss out anything essential. So that is what we are going to see today. Now, in the first, what I am going to do is, first, I am going to draw two vertical dotted lines. The first step is drawing two vertical dotted lines. Now what these dotted lines represent? These dotted lines represent the scope of my design. You understand? These dotted lines represent the scope of this design, and in the dotted lines I first write left to right, I put an arrow, and right how, and right to left I put another arrow and say Y. I'll come to it later. So first of all, for me always the context is very important. You should very clearly understand what we are doing and why we are doing it. What is the context? To design a product, I have to identify the various functions that the product is to perform. So we are talking about functional decomposition of a product. That is the overall picture. We are today talking about the functional decomposition of a product. Now for that, we are trying to learn a systematic procedure, a systematic approach by which the various functions to be performed by a product can be identified. Is it okay? For that we are learning the technique called FAST. Now, how do I start with? I start with two dotted lines. My entire design is within these dotted lines. My entire design is within these dotted lines. So here the requirements are going to come in. Okay. Here some way of achieving that is going to come. I'll come to that later. Construct two dashed vertical lines, one on the extreme left and the other on the extreme right. These lines define the scope of the product development objective. Any doubt so far? So these vertical lines, they encompass my design objective. Have you all constructed it? Sir, have you constructed it? To the right of the left line, this is the leftmost line. To the right of it, place the basic function. To the right of the left line, place the basic function. Is it okay? Now suppose, let me take a product and then do it, then only it will be easier. Is it okay? Let me take, my job is to design an iron box. Design an iron box. Okay? So what is the function that it is supposed to perform? What is the function that an iron box is supposed to perform? What?
Iron the clothes.
Iron. Okay, iron box is meant for ironing. Great. Can you put it in some other words? Technically, how that iron, what function does an iron box do? Good. It generates heat. Then what else? What else? Is it just heat? Can I just use steam and then do ironing?
Plane surface.
What?
A plane surface.
Okay, number 2, a plane surface is required, a flat surface is required, so it should be solid. Okay, suppose you want to iron your jeans.
Force.
Will you do it at home or will you give it to somebody else? Generally, ironing jeans at home is very, very difficult. What do? You give it to the outsider. Why? What is the difficulty in ironing jeans rather than a pant?
Thick. It is very thick.
What?
Very thick.
Very thick, so what?
So it's difficult to iron.
What do you need?
More force.
More heat.
Force.
What? More?
Force.
What sort of force?
Manual.
Okay. One, you require a compressive force. You have to push it down. You have to compress the cloth. But, so that can be achieved by having a higher weight for the iron box. Is it okay? So, there are 3 things that my iron box does. A heavy, flat, hot surface does the job of iron. Is it okay? So, what is my objective? Ironing is my objective. Ironing is my objective. Now, how I am, if you proceed in this diagram, if you proceed from left to right, you will get the answer how. If you proceed from left to right, you will get the answer. Answer for the question, how? How am I going to iron? I am going to iron by using, yes,
Pressure.
a hot, flat, okay, flat I'll remove because I don't want too many words here. Are you able to see what I'm writing? So I'm going to have hot, heavy, plate. Plate is flat. So the characteristics is taken care of. I'm going to get, how I'm going to get ironing? How I'm going to get the ironing done? Ironing is going to be done by using a hot, heavy plate. Nice. If you ask the question how, you will travel from left to right. On the other hand, hard. Why is right to left? Why do you need a hard, heavy plate? Why do you need it? To do iron. So you join them. So let us see the steps first. To the right of the left line, place the basic function. Ask, why is the basic function? Why is the basic function is being performed? Why a basic function is being performed? Why is this not proper here? Why the basic function is being performed? This is the basic function within my design domain. Why this is performed? Why this is performed? To do iron. Is it okay? A higher order function will answer this question. Place this to the left of the basic function and connect with the line, and you are beginning a critical path. Now, designing an iron box is something given to me. I don't have a choice. As a design engineer, I have been asked to design an iron box. So that is outside my scope. Designing iron box is something given to me outside. Do you understand? But how do I reach that? By asking why here? Why do I need a hard, heavy plate to perform ironing? Or given my job is ironing, how do I arrive at this? How do I do the ironing? I do ironing by having a hot, heavy plate. That right. Next slide, please. Now the first 2 points you are able to understand well. Okay. Now, generate functions to the right of the basic function by asking how. Now, how do I get a hard, heavy plate? How do I get a hard, heavy plate? So first, let me go to the hard part of it. Okay, I have a heating coil. I have a heating coil. The heating coil will generate the necessary heat. Okay. I can also have thick metallic plate. Why thick?
Heavy.
Because I want it to be heavy. Okay. Well, why thick? Because I want it to be heavy. Why metallic? It should conduct heat. Okay. Plate. So how this is achieved? This is achieved by having a heating coil. Because I don't have enough space, let me write it. Let me write it here itself. So heating coil with thick metallic plate. So a hard heavy plate. How do I get a hard heavy plate? How do I get a hard heavy plate?
By heating.
You have a heating coil with a thick metallic plate, you will get a... Why do I need this? Because I need a hard, heavy plate. Is it okay? So the third point is generate functions to the right of the basic function by asking how. And the answer to how, I have to keep on adding how. I have to put another how here. Okay. So you keep on adding it. It leads to a secondary function. Connect these functions implement these functions using lines, okay, to continue the critical path. To continue the critical path. So how do I get a heating coil? Okay, how do I realize a hot coil? I realize a hot coil by having a controlled current flow. I will realize I'll get a hot coil by having a controlled current flow. How do I achieve this? I achieve this by taking the power from the mains. Why do I cross the vertical line and go? Because power from the mains is not within my design scope. I presume that there will be a plug point to which I can plug my iron box. Are you following it? See, please note, it is better you learn it very thoroughly here, because in your assignments and in your tests, you are going to perform fast at different products. I'll just like that give a product and then ask you to perform a fast. So better you learn it. So why do I draw the, how do I get the controlled current flow? By plugging it to a socket. But that is drawn outside the vertical line because I'm not going to design the socket. I'm not going to design what should be the voltage. I'm not going to design what should be the frequency. This is beyond the scope of my design. This, I presume, it is provided by an external agency, so this is taken for granted. Now the fourth point is, the critical path will end with an assumed function. What is the assumed function? Power from the mains is the assumed function. What do you mean by assumed function? It is assumed that a 220 volts AC power supply is made available for my appliance. So this is an assumed function. So the rightmost box, that is the box outside the vertical line, outside the right vertical line, will indicate an assumed function. The critical path will end with an assumed function outside the right scope line, like supply electricity, or provide muscular power, or apply force. Suppose I am designing a braking system. Okay, I am designing a braking system. At the rightmost end, what will you have? At the rightmost end, okay, brake pedal is pressed by some human being. Okay, that is the assumed function here. Okay, suppose I am designing a nail clipper. I am designing a nail clipper. What is the assumed function? Okay, pressing by the human being is the assumed function. Do you understand? Right. So this line is called the critical line. The critical path will end with an assumed function outside the right scope line, like a supply of electricity. Have you understood? So far, I have only 2 more steps to be performed. Next slide, please. Generate the remaining secondary functions. Generate the remaining secondary functions by placing them under the functions. These occur at the same time or caused by the function on the critical path. Okay. For example, here, okay, overheating of hand, overheat exposure to so I am going to have a hot plate get cold and that. So I should not get any, my hand should not be exposed to heat excessively. So I must safeguard. Again, this is a secondary function. I generally put it under double box. What do I put double box? This is generally which is not desirable, but is likely to happen. Or here I can have shock. I could experience an electrical leakage and experience shock. So these are all the secondary functions. When I have a controlled current flow, I can always have the shock. I have a hot plate, I can have my hand exposed to heat. So these are the secondary functions that I must be careful against. Then finally, state the objective of the development effort above the basic function. And in addition, add one-time or all-time functions on top of the diagram. There are few things called one-time function and few other things called all-time functions. See, for example, any product that is designed, okay, this is an iron box, okay, this iron box must have an aesthetic look. This iron box must have an aesthetic look. It should have a pleasing appearance, is it not? Okay. So this is an all-time function. Is it okay? The iron box, okay, must be, when not in use, it must be packaged properly, because the flat surface should not get hurt. Okay. So some package. During transit, it should be packaged properly. During initial transit, it should be packaged properly. These are one-time functions. Okay. These are represented on top of the diagram. Now, let us go to the next slide and see the whole construction. Next slide, please. So this is the fast method. Okay. Now the one-time functions and the all-time functions are put under the dotted box. Okay. The one-time functions and the all-time functions are put under the dotted box. You have a higher order function on the left. The leftmost is the higher order function that is above the scope of design. It is something which is given to you. To design an iron box is the task given to you. I cannot question that. So that is the higher order function. So the critical activity, it starts with the basic function. Is it okay? Then you have the required secondary function. What is the primary function? You need a hot heavy plate. How do you get a hot heavy plate? By having a. So again, I can have another required function. Okay. And how does the critical path end? The critical path, it always ends with the assumed function. What can be the assumed function? It can be the electricity from the socket. It can be the leg action of the driver in the case of a brake. It can be the movement of the fingers in the case of a nail cutter. Okay. It can be the movement of, suppose if you are designing a scissor. The scissor is operated by your thumb and the index finger. So the movement of the thumb and index finger is the assumed function for a scissor. So in the rightmost you have the Assume the function. Now what do you have below the basic function? Functions that happen at the same time are caused by the critical path function. When you are heating the plate, you are also heating your hand. When you are providing electricity to the coil, you should not provide electricity to the person who is ironing it. So the functions that happen at the same time and are caused by the critical path function, they are listed here. Then you have the unwanted functions. These are some of the unwanted functions here. Okay. Now the two vertical lines, they encompass, they show you the domain of the product design activity. Is it clear? Any doubts you have? Okay. Now I'll take up a practical case and then see how it is done. Next slide, please. Now this is the fast for a coffee mill. Coffee mill is, you have a roasted coffee beans. Okay. The roasted coffee beans you have, and you want to make them into a powder and then use it. Well, what is the point? Because the coffee powder cannot be stored for long. The coffee powder, as it becomes fine, okay, it will lose its aroma, it will lose its smell if it is stored for a long time. That is why your mom will not buy a coffee powder for long. Coffee powder is not bought in 2 kg, 3 kg, no. It is always bought in small quantities. The reason is, it will lose its aroma because it is a small powder. The surface area is more, something small, the surface area is more, so it will lose its aroma. Is it okay? So if you store coffee powder, the storage life is going to be very short. On the other hand, you can have the roasted coffee beans stored at your house for years, nothing will happen. It should be kept dry, that's all. So whenever you require a coffee powder, you just put it into a coffee mill and then it will generate the required powder. So what you are trying to do is design a coffee mill. Is it okay? Now are you able to see the two vertical lines? The two vertical lines, they represent the design domain. Is it clear? The two vertical lines, they represent the design domain. Now, what is the first objective? The first objective is to chop beans. The beans, the coffee beans, they have to be chopped and made into small powder. That is the objective of this particular machine, this particular product. Okay. Why should I chop the beans? Because I have to grind the coffee. Is it okay? I want to grind the coffee. So, if you ask at any box, if you ask the question why, you will travel to the left. And at any box, if you ask the question how, you will travel to the right. Why you want to chop beans? Because I want to grind coffee. Okay. So to chop beans, what do I need?
Blade.
I need to convert electrical energy. How do I chop beans?
Blades.
I convert electrical energy into
Mechanical energy.
into rotation. I convert electrical energy into rotation. And I am retaining this because there are few more syntaxes that have to be followed. I am retaining this diagram. Okay. What I did was, first I explained in layman terms how this is to be performed. This fast analysis needs to be further refined That's why I am reading this. I will come back to this. Okay. Now, how do I chop beans? I chop beans by converting electrical energy into rotary motion. Okay. Now, how do I convert electrical energy into rotary motion? By the actual electrical power. Where do I get it? I have to, the electricity is to be provided. So, in the right extreme, I have the assumed function. What is the assumed function? Provide electricity. Is it fine? Right. So, electricity is provided, the actual power is received, that electrical energy is converted into rotary motion, that chops my beans, and then I achieve grinding of coffee. Now, what are the secondary things? While chopping beans, I should provide a seam. Otherwise, the beans will get exposed. Okay, the beans will get exposed, it may spill, it may come out, so I should provide a seam. Number two, I should contain. All the beans, it must be contained within the container. I must provide a container into which the seeds are housed. So contain beans. Then hold beans. When the rotary motion is provided, these beans are going to be thrown here and there. So I must hold the beans. I must accept the beans. There must be some way by which I can put in the beans. If you see actual coffee grinder, there will be a hopper which continuously feeds the beans. So I must accept the beans, and this crushing process will generate a noise. Is it okay? This generation of noise is put under a down line because it is an undesirable effect. Then I should have some systemic response to it to reduce the noise. Is it okay? So what is the overall objective is? The reduce noise. Now when you convert electrical energy into rotational energy, okay, the energy is generated and that needs to be transmitted to the torque needs to be transmitted to the blades. Okay, then there will be a lot of vibrations generated. That vibrations are to be damped. This also, the torque transmission, vibration, everything generates noise. Again I have to reduce the noise. Now the actual power is achieved by connecting to the electricity. And what are the overall objectives? I have to reduce noise. It should be a compact system. My coffee grinder cannot be so huge. It should not occupy my entire kitchen space. It should be compact. It should create an aesthetic appeal. Then there are some universal. Then you go back to the previous one. See, there are certain all-time functions. Which are true for any product. Like supporting loads. Okay, can we go back to the current slide? Supporting loads. Whenever a mechanical component is subjected to loads, that must be taken care of. Aesthetics, compactness may be more important in certain situations or less important in certain other. Is it okay? So these are certain things that are universal and these are all-time concerns. Now what I want you to appreciate from this particular slide is inside each box, this is another important aspect, inside each box generally we have a verb followed by a noun, an object. Okay? Now see everything. inside every box, you have a verb, you have an action. Function means to do something, to act. So inside every box, you have, this is a specific format in which you have to write your, this is the specific format in which you have to write your first analysis. So you have chop being, chop is an action. Seal, contain, hold, accept, generate, reduce, dampen, transmit, convert, acquire, connect, provide, grind. So every box, it starts with a verb, okay, action, and the next thing is what is being acted upon. Okay. So can I rewrite my first analysis following this particular clue? Yes? Can somebody suggest me?
One.
This is the action that I want to perform. Okay. So you first heat a plate. So how do I achieve this? Convert electrical energy into heat energy. How do I do this? Acquire controlled power or controlled power. Provide electricity. Prevent overheating. Or it is generating heat, overheat. Okay. Leak current. Okay, if you have a leaky current, that leads to the short circuit. Is it okay? So the whole analysis, the whole fast analysis is to be performed with certain verb followed by an action. Okay. Now today I am going to give a small homework. It is not an assignment. What I am going to do is I am going to in the forthcoming class, coming Thursday, I am planning to do fast analysis for 2 components. Okay. Before I do that, and after that I will give an assignment on it. Before I do that, if you do this exercise for a simple component, for some simple components, then you will be able to appreciate it better when I do it in the next class. So a small homework in which you will do okay, the fast analysis on okay, a name clip. What is so big in a nail clipper? What is big about a nail clipper. Why you are able to cut the nails easily with your nail clipper? Not even with the scissors. You are able to do it much better with the nail clipper. Have you ever wondered it? Yes? Why you are able to cut the nails very easily with a nail clipper? Have you ever wondered it? Shape? No, anything. No. No, that's all fine. See, nail clipper is something which has very high mechanical advantage. You study a nail clipper, it has a very large mechanical advantage. You require, please believe me, you require a huge amount of force. Nail is a hard skin.
Small area.
It is a hardened skin. It requires a huge amount of force. So you need to have a large amount of mechanical advantage. So it is, you study, take a nail clipper and study which is the fulcrum point, which is the load application point, that is the effort point, and the load point. In any fulcrum system, you should have studied in your high school physics, there are 3 points. A fulcrum, the point where the load is actually applied on the object, and the point where the effort is applied. The effort point, load point, and the fulcrum. Do you use a different terminology? The loading point, the effort point, and the fulcrum point. Okay. These, the ratios, they determine the mechanical advantage. In a nail clipper, the mechanical advantage is huge. You achieve a large amount of mechanical advantage. So probably you perform a fast analysis on a nail clipper. We will work it out in the, we will take some other product and then we will do the analysis in the next class. Is it okay? Now we go to the assignment part. So the term assignment 2, okay. The term assignment 2 is on toy design. Okay. So what will be, all of you have been asked to bring 20 rupees today. Okay, you can give that 20 rupees to your class rep. Class rep can contact the faculty member. Okay. You will be given a toy. Okay. You will be given a toy. And what is the objective of this particular assignment? Next slide please. The objective is to view and study a toy from the product designer's perspective. Please believe me, this toy is not given to you to just play. Okay, our faculty members have taken a lot of effort to go, procure it, bring, sort, all that. It is not given to you to just to play with it. The objective is to view and study a toy from the product designer's perspective. What is it? What is the product designer's perspective? To view a toy as a product and not as a plaything. A designer, I mean, it is a plaything, no doubt, but what is the point of view is different. You have to view it as a product. What does it mean? That is, a product, it is functional. A toy is performing certain function. So are you able to identify how that function is performed or what the function is being performed? Right? Then number 2, it is made up of certain materials. Number 3, it has to be manufactured. A toy needs to be manufactured. And number 4, it costs. A toy costs something and each part within also costs something. So far you know that a toy costs something because you are paying from your pocket. You are going to pay 20 rupees today. So all of you know it costs something. But each and every part of it, it costs something to manufacture. So these aspects you need to realize, and that is the objective behind the whole assignment. Okay. Probably I will distribute the assignment sheets. Okay. I will distribute the assignment sheets and we will continue this. First, What are you supposed to do in this assignment? Next slide please. Now first, you have to dismantle it carefully. These toys are very fragile. Okay. It will be ideal if you could dismantle, assemble it and still it is in working condition. So dismantle it very, very carefully. Okay. And if it is a very fragile toy, you can also prepare. There is an option to, there is another alternative to dismantling, that is preparing a cut section. Okay, in your design appreciation lab, you would have seen cut section of certain gearboxes. Okay, you can go there, look at it once again. If necessary, you can prepare a cut section. The second step is you have to draw a schematic diagram of the whole toy and briefly explain how it works. Okay, I want you to, these are all not very exotic things. We bought it from the market only, locally available toys. You might have seen most of them. Okay. But what I want you to do is, you have to explain how it works. How this particular toy works. Okay. Suppose it is a toy in which you operate some key. That means, I'm not going to elaborate, you are supplying some energy. How that energy is received, how it is stored, how it is dissipated, you have to study the energy flow. Okay? So what I want you to appreciate or explain is how the whole toy works. It performs certain functions. How these functions are performed. How it works. You have to make a schematic sketch. At this stage, don't bother to draw the exact figure. Suppose I am giving you a bird, I am not interested in the shape of the bird. But what that bird does, how it is done. So you have to draw a schematic diagram. Please don't draw a beautiful bird diagram and then cover up whatever is inside. I am not interested in that. I am interested in the working schematic diagram. Now after you have identified how it works, you identify just 3 important parts. It should really be important parts. In any system there are few critical parts. Naturally, these critical parts will be complex also. You take out these critical parts, using a plain scale, you measure all the dimensions of these critical parts, draw the 3 views of these critical parts. I am asking the drawing of 3 parts alone. Okay, you have to make this drawing in AutoCAD or in any other drafting package, all the 3 views with the dimensions. Take a printout, attach it as part of the assembly. Identify 3 most important components that are essential for the functioning and prepare 3 views of these parts, 3 views of each of these parts using a drafting package, enclose it as part of the assembly. It carries some mark. Is it okay? Again, I need not repeat it. If it is purely copied from someone else, now this time what we are planning to do is, we will segregate all the assignments based on the RRN number. Okay, because we want to select the best assignment, and the best assignment, whoever wrote the best assignment, he will be asked to present the assignment for 5 minutes. Okay, so we are going to correct it according to the RRN number. So I will be correcting all the assignments written about, say, helicopter. So I will easily identify if 2 assignments are identical, in which case both will be awarded 0 mercilessly without any consideration. Okay, I have told you how we are going to evaluate. Please don't be foolish to copy. Okay, I am going to correct maximum 22 assignments of helicopter. If 2 assignments are identical, I can very easily identify. And both of them will be awarded 0. So, because I need to correct this way because I have to identify the best assignment. And he will be presenting, whoever had done the best assignment, he will be presenting it for 5 minutes. So, the last 3 aspects, what are the materials that could be used in making various parts? Elaborate how these parts could have been manufactured. Please take it from me, you are going to study, I am sure about mechanical engineers, for aeronautics I am not very sure, but it cannot be radically different. About materials, all mechanical engineering students will study at least 2 papers. One on material science and another on metallurgy. Okay. We are fully aware that you have not studied that yet. But still, I want you to explore and see, okay, what are the different materials that could be used? Because I want you to have an idea about materials. What are the various materials available? If necessary, I will give a small introduction today. I want you to appreciate the need for different materials in different engineering applications. About materials, we will have an introduction later. Now also, not only materials, but these products are to be manufactured in particular shape and size. How these parts could be manufactured? Again, we will be studying 2-3 papers on production technology, manufacturing methods. We are fully aware, you have not studied these papers, but at least think while. Imagine how you could manufacture these parts. Now the last question is, assume the total cost of the product to be 10 rupees. It is approximately 10 rupees. Cost of the product, not the price. What is the difference between the cost and the price? Cost is the expenditure incurred by the person who is manufacturing that particular product. Price involves cost involved in transportation, shipping. Most of these toys they are made in China. Okay, the toys that will be distributed to you, most of them were made in China. Okay, so they had to be transported in huge containers. They were shipped from China, and there were 4-5 intermediaries. So everyone needs a profit. There will be an exporter there will be an importer here, then there will be a wholesale merchant. So the cost of the product is only 10 rupees. Okay. Then please don't ask me why are you collecting 20 rupees. Okay, believe us, it is not for the department or any one of us. The cost includes the third assignment cost also. And also all these overheads. These are called overheads in engineering. Okay. The cost incurred in transportation, profit at different places. So assume the cost of manufacturing is only 10 rupees. Then you have say 10 parts. How will you distribute? There is no right answer or wrong answer here. I want you to really assess each part. How will you distribute the cost to, say if there are 10 parts in the product, how will you distribute the cost to various parts? Is it okay? This is what I want you to do, and there are marks associated with each of them. Okay. So you have to do it carefully, and the due date is also given, is it not? When is the due date? 20th is the due date. Please don't wait for the due date. You are always welcome to submit it earlier. Next slide, please. Now today these are the toys which you will be given. Okay. RRN ending with 0 is earth mover, 1 board on wheel, 2 is a spring loaded gun, 3 is small car. This you will be giving in 2 numbers, is it not? This you will be given in 2 numbers because it is very fragile. Even if you break one, you can use another. The fourth one is a top. Fifth one is a helicopter. 6 is a photo viewer, 7 is elephant drum, 8 is water gun, 9 is a big car. Okay? Yes? Photo viewer is something in which you will have some button pressed, you will see different photos coming before you. Number of them. Okay? Right? You will be given, don't worry. Your class reps, please meet the concerned faculty. They will give you, go with the list. They will give you how to distribute it according to the RRN number. Please, no exchange of toys, whether you like it or not. Okay, don't say I don't like this particular toy, I want to exchange. No. That's why I said at the beginning itself, this is not for playing, rather it is to view it as a product. Next. Now, we are going to enter into 3 domains. Okay. Through this assignment, you are going to enter into 3 domains about which you don't have any clue. You may not have much of ideas. The 3 domains are materials, manufacturing, costing. Knowing fully well we are asking you to do this exercise, so I thought it will be fair on my part to give an overview of these 3 domains in roughly 20-30 minutes. Believe me, when we talk about materials, there are millions of materials that are used by engineers. There are millions of materials that are available for engineers to choose from. Okay. Now, people whenever they refer to anything, okay. Now, can you tell me what is the material of this clip? Pardon? Material of this clip? Steel?
Steel alive.
Wait a minute. If somebody says steel, please take it from me. There is no single steel available. There are thousands of steels available for an engineer to choose from. There are thousands of steels. If somebody says stainless steel, please believe me, it is not stainless steel. Okay, this material is not stainless steel. If somebody says it is stainless steel, again, there are 3-4 families of stainless steels that are available for you. No, not 3-4 families of stainless steel that are available for you to choose from. Now, all that I want to appreciate is material. The world of material is huge. You have a huge choice. So what is essential is, first, you should appreciate. And what is this material? This transparent cover? Again, the same thing. There are thousands of so-called polymeric materials available for you to choose from. There are thousands of polymeric materials available for you to choose from. So let me take the steel alone. Because as a mechanical engineer, I am comfortable with steel. Okay. First, steel, by the word steel, what we mean is, what do you mean by a steel? Generally, what do you mean by when you say steel? Okay, the first thing is an alloy of iron. Generally, iron alloyed with carbon alone is called steel. Iron alloyed with carbon alone is called steel. Iron alloyed with some other alloying element, it is referred to as alloy steel. So if any material contains pure iron and carbon alone, it is called steel. Steel is categorized into basically 4 types. A low carbon steel, a medium carbon steel, or a high carbon steel. If the carbon percentage is say less than 1.2, then it is called a high carbon steel. If the carbon percentage is roughly more than 1.2, it is no more called steel. There is another name. Can somebody tell me what it is? When the carbon percentage is more than 1.2 or 1.6, it is called, yes, can somebody give me the name? It is called cast iron. When the carbon percentage is more than 1.2 or 1.6, it varies. Okay. People call it as cast iron. Cast iron itself, there are some 10-15 types of cast irons. I am not talking based on the percentage of carbon alone. Based on percentage of carbon, again I can categorize it. There are 10-15 types of cast irons. There is something called a grey cast iron. There is something called a sporoidal cast iron. There is something called a nodular cast iron, white cast iron, malleable cast iron, all sorts of things are there. So this is within the family of iron. Iron is a base metal. If you add carbon alone, what do you get? Steel. What are the different types of steels? Low carbon steel, medium carbon steel, high carbon steel. Then if you add more of carbon, you get cast iron. In cast iron you have varieties of cast irons. Then what do you have? You have alloy steels. What are alloy steels? Iron plus certain other alloying element like nickel, chromium, tungsten, vanadium, molybdenum, manganese. These are all the various alloying elements which can be added to steel. Each has its own influence. Okay. Stainless steel. Hundreds of stainless steels are available. Is it okay? So all that I want you to impress upon you is, materials is a world in itself. I have to select material very carefully for any application. Probably I'll spend another 2 hours at the end of this semester discussing exclusively about materials and mechanical properties. Okay? Now since I have asked you to talk about materials, I thought I should give you a very brief introduction about materials. Next is manufacturing processes. Basically, there are 3 types of manufacturing processes. Whenever you want to make a material, there are basically 3 ways by which it can be done. The first thing is, you melt it and pour it into a cavity. That is one way of doing it. The first way of doing it is, you melt it and pour it into a cavity. You prepare a mold, you melt the metal and pour it into the cavity. This is one way of doing it. The second way of doing it is, you don't melt it, but somehow you deform it to the shape that you want. You apply force. Okay, I want a wire to be bent in a particular shape. I just bend it. I don't melt it and pour it into that shape. I have a rod. I want it to be converted into an L shape. I have a rod. Okay, I want to just convert it into the shape of a hook. I have a rod. Okay, I want it to be converted into a shape of a hook. Try to bend it. This is what people do in construction, isn't it? They bend it. All the rods are bent into different shapes. The first one is called a metal. With reference to metals, the first thing is called a metal casting process. The second one is called the metal forming process. Casting is what? Melting and then pouring into the mold of the shape that you want. What is the second type? Metal forming process. If I were you, I will note down these things. Metal forming process is bend it or deform it to the shape that you want. The third one is called a metal cutting process. What do you mean by a metal cutting process? I have a rod like this. I want to make a step shaft. Okay. In this, you cut out the remaining unwanted portion. You remove all these portions. The third one is called the metal cutting process. Next slide, please. I would have elaborated the 3 manufacturing processes. I have added 2 more, but those 2 are secondary. First, by melting and pouring. Casting, metal casting comes in this category. Generally, when it comes to polymers, when it comes to plastics, you manufacture it, you refer to them as molding. So melting and pouring, you have casting processes, injection molding, okay? All the moldings, they come under the melting and pouring route. The second one is by material deformation. Forging, forming, rolling, these are all the various manufacturing processes. Extrusion, these are all the various manufacturing processes, okay, that use, that get the required shape by. So you have the material deformation, that is, you apply mechanical force, deform the material to different shapes. Okay, that is called material deformation, metal forming. It is called metal forming. Forging, forming, rolling, etc. They come under this category. The third category is cutting. You want only a small part of it wanted. The remaining part is machined and removed. That is called the metal cutting process. Milling, shaping, turning, grinding, EDM. These are all metal cutting processes. But EDM is electrical discharge machining. That is again a metal cutting method. Then you have something called, you have the third, the fourth and the fifth thing are not very important. You have various joining methods. 2 metals are to be joined together by welding, riveting, fastening, bolts and nuts, screws. So that is the joining technique. And there are a few other advanced techniques like powder metallurgy, okay, solid state sintering. So these are all certain advanced methods by which materials can be manufactured. You can conveniently forget about the last 2. At least the last, you can conveniently forget. The 3 methods are, you melt it and pour it. 1, you apply force and deform it, change the shape. 2, cut and then remove the unwanted part. 3. The first one is called metal casting. The second one is called metal forming. The third one is called metal cutting. I just have few pictures of these processes. Probably you can appreciate it better. Next slide, please. This is casting. We have molten steel. Okay. There are beautiful videos available. You just go to Google, type metal casting, because whenever I put videos, I hear all the writing pads making noise. So I thought I will restrain from it. I'll just give the clues. Those interested can see. You just go to Google and then type metal casting and ask for videos. You have huge, large number of videos available. Okay, this is molten iron. What the person is trying to do is, the molten iron will have a low melting point constituents called slag. These slags will be floating on top of it. Okay, they are impurities basically. That should not come into my cast. So he is trying to just push away the impurities so that only the heavy metal will come into the cast. Here you have a mold. The shape into which you want this molten metal to come and fill. Next slide please. Again, you can see it. Okay, the molten metal coming and then filling a mold cavity. Okay, So this is basically a metal casting process. This is a metal casting process. It can be, aluminium can be cast. The advantage of this is any complex shape can be manufactured. Any complex shape can be manufactured. This is one of the oldest methods by which man was able to make use of metals. All the traditional icons, your images of gods, all the statues, they were made by metal casting techniques. Next slide please. This is one of the metal forming process. One of the metal forming process called rolling. What you do is you have two huge rollers. These rollers, you might have seen somebody squeezing out the juices from sugar cane. You have two rollers. You put a sugar cane. What happens to the thickness of the sugar cane? It gets reduced. So what here you do is you set a huge plate. You set a huge plate between two rollers. The thickness will get reduced and you'll get a sheet coming out. So this is one way of, this is one of the metal forming process. Okay, next slide please. You have the rollers here. You have the rollers here. Okay, somebody sent a thick plate from this side. The thickness got reduced and then you have a thinner plate at this side. Successively you can do it. This is called hot rolling. This particular process is called hot rolling. This hot rolling can be done at room temperature also for certain materials. And there are a lot of things that you can study about hot rolling or cold rolling. There are at least some 20 metal forming processes. You understand? There are at least some 20 metal forming processes. So I am just giving an overview of this. Okay. The next method is called the metal cutting. So this is a metal cutting. This is typically a lathe. Okay. So always don't think that lathe is something small. Okay. There are huge lathes available. There are lathes which can hold jobs that are say 10 meters length, because maybe for many applications we have huge shafts. So your lathe must be able to turn those huge shafts also. So here, whatever shape you want, you retain the remaining portion, you cut it out. You cut and then remove the remaining portion. That is the purpose of metal cutting. Is it okay? Now what I have tried to do is, I have tried to give an overview of materials and manufacturing processes. Okay. This is just to enable you to do well in the assignment. The objective is you have to think in terms of materials and manufacturing processes. That is the objective of the assignment. Okay. Take it very seriously and do the term assignment well. All of you might have received the first assessment. If you have any grievances, you talk to the concerned faculty and sort it out immediately. The moment the assessment mark is frozen, it cannot be changed. And some of you have not submitted the assignments. That means, I have told in the very first class, I am repeating again, that means you are losing marks. And subsequently your grade will be falling down. And there is no substitute or for the assessments, for the assignments, there is nothing called substitute or improvement. So you have to act in time. And those who have missed the assessment test, please, already the date is over, but I can extend it for a day or two, immediately apply for a substitute test. If you don't apply and get permission within a week of the examination, you will not be allowed for a substitute test. I don't know whether you are aware of. Are you aware of the provision for the substitute test? Okay. If you have missed on health grounds or on some valid reason, You can apply within week for a substitute test. Okay, if you want to apply, do it immediately within a day or two. Otherwise, you will lose the marks. Any other questions you have? Any doubts? Any doubts? Any questions?